Thank you. So picking up on our lesson from yesterday, we're doing a further study of stretches and compressions, and all of the graphs that we're going to do today will have a double transformation. In this situation, we have an A that's 4 and a B that's 1/2. So that's a vertical stretch and a horizontal stretch. Or we'll do a vertical compression, a horizontal compression. I already said this to you, but I forgot to say it on the video, so I'm saying it again. Horizontal stretch, vertical compression, or horizontal compression, vertical stretch. So all the different combinations of a double transformation. So we're going to start with this equation here. You'll notice the one difference is in theta instead of terms of x. Be flexible and be able to go back and forth between them. Okay, and the other thing is this might not feel like a very comfortable version. It might seem a little hard to see that your B term is half. It is definitely fine for you to write an alternate version of this equation. So for tangent of 1/2 theta, 1/2 times theta is the same as theta cut in half. Okay, so one thing I used to tell when I taught 7th grade, and they would have to separate like their x from the fraction, is I'd have them draw the coefficient of the x, and it would kick the x off the fraction. So 1/2 x. It's true. If I multiply that, 1/2 times theta, theta over 2. Same thing. Okay, so amplitude. 4? Yeah. Period. Pi over absolute value of 1/2, which is positive. So pi over 1/2 is the same as pi times 2. So 2 pi. Right phase shift, which we're asked to find. It doesn't have a C term, so 0/2 is 0. Tomorrow we'll do notes on phase shifts. And then one cycle. Remember that we start one cycle, the tangent function, at negative pi over 2, less than bx plus c, so that would be half theta, less than pi over 2. And what we're going to do is we're going to move the horizontal asymptote, the vertical asymptote, by isolating theta. So if you're okay, I don't wish to create a complex fraction here. I'd rather just multiply by the reciprocal. So I'm going to multiply everything by 2. Also, I can imagine if I multiply everything by 2, it's going to cancel out all those denominators. So here we have negative pi less than theta less than pi. So I told you at the beginning of this lesson before I started the video that I started thinking about how to draw this graph in one iteration instead of multiple graphs with multiple transformations. So what I like to do is think about just drawing one branch of the cotangent or the tangent function where I have an asymptote on one side at negative pi. I have an asymptote on the other side at pi. And I know that between these two values, I need 4 equal sections. So I need 3 of my critical points in between my two asymptotes. So right here, dead center is my y-axis. So I'm being thoughtful about that placement. And on my y-axis, I'm going to go ahead and put in my amplitude as my critical point measure on my y-axis. And then I'm going to split the difference between those two so that I get 4 equal sections. So I'm going to have a point at negative pi over 2 and a point at pi over 2. So what I'm doing here is I'm drawing the final picture of my function. Remember, tangent starts down low, hits the center, finishes high as it approaches the asymptotes. So this graph is going to start here and curve through the 0. Sorry, my pen's acting kind of silly here again today. And then what I just like to do on each side of when I have a little more room, I just show that that pattern is going to continue. So over here, I would draw a little bit of a picture as well. Not perfect, but that was my thought process. I'm using the cycle and my horizontal stretch to find my asymptotes' new locations and then graph them, cut the distance in half, and then cut that distance in half again, and plot my amplitude stretch or compression, whatever it is, hit my 3 points, and then duplicate. Questions? Okay, so here's what I'd like you to do. You do B. It's a cotangent function. I'm going to press pause, you press pause, try it out, and then press play and see if you got it right. Okay, so you should have found an amplitude of half, a period of pi divided by 2, a phase shift of 0, and then a switch with the horizontal compression of 0 to 2 theta to pi, compressed to 0 to theta to pi over 2. So I'm using 0 and pi over 2 as my asymptotes. And then between them, I'm going to do my 3 critical points. So I cut it in half and then cut it in half again into 4 equal sections. She is not here today. Madeline, are you here? No, she's not here. And then cotangent starts up high. I put in my amplitude of half and negative half. Starts up high, hits the 0, finishes low. Did a couple of cycles so that you can see the periodicity of the function. Question?
On the test, we drop as points, we don't go all the way to pi, or if we just go to 2 pi and have like...
If your graph is correct, I'm not going to knock you if you don't have multiple cycles. Okay? All right. Questions? Okay. So that's some practice with tangent and cotangent. On the back, let's do a practice with the secant and cosecant, and then you can go ahead and start your assignment. So here we have on the back, y equals half a secant of theta over 3. Again, that could feel really uncomfortable, so I'm going to put the coefficient of theta, which is a 1, and he's going to kick theta off. So we have y equals 1/2 secant of 1/3 theta. So it's a little easier to see your B term. So your amplitude is half. Period of secant, because it's a reciprocal of cosine, right? So we're going back to a period of 2 pi divided by your B term, 1/3. And we don't need absolute value since it's positive. So that's 2 pi times 3. Period of 6 pi. So we'll definitely be drawing one cycle here, unless you really want to make the distance between 0, or the distance of 6 pi like really close together. That'd be kind of weird. Phase shift, 0 over 1/3 or 0. And one cycle is secant. You have to remember that the secant function is a reciprocal of cosine. And when you draw cosine, you want to get one whole section up and one whole section down. So you have to start back here at negative pi over 2, because, you know, at theta is 0, you're up at 1. Or in this case, you're up at 1/2. And then you get your other 0. And then you finish over here at 3 pi over 2 for one full cycle of the wave up the opening, well, the wave that maxes out and the wave that minimums. One peak, one valley. So we're going to start at negative pi over 2, less than 1/3, that's a 3, theta, less than 3 pi over 2. And then we're going to solve for theta. So multiply times 3 so that I do not have to create a complex fraction. You guys okay with me multiplying by the reciprocal?
Yes.
So times 3 times 3 times 3. All right, that gives me negative 3 pi over 2, less than theta, less than 9 pi over 2. and I've been giving this advice to the other classes today, that's a distance of 6 pi, but it's difficult to see. If you were to change this to decimal form, this would be negative 1.5 pi. Okay, less than theta, less than 4.5 pi. Can you see the distance of 6? Yes? So if you wanted to, my personal preference in this situation would be to convert to decimal form. It's easier for me to do some division, because you have to remember that secant has 3 asymptotes, of which these 2 are on the ends, and then there's one right in the middle between them. Secant has 3 asymptotes and 2 critical points. So I'm going to start my graph at negative 1.5 pi, going to finish my graph over here at 4.5 pi, and I'm going to think about that. That's a distance of 6 pi, that's the period. And so half of 6 pi is 3 pi, right?
Yes.
So if I subtract 3 pi from 4.5 pi, I'm at 1.5 pi. So you can see a distance of 3 pi in both directions. True? And so I'm going to have an asymptote here, and an asymptote here, and an asymptote in the middle. And then 0 would be your y-axis right here, with an amplitude of half, a negative half. So that's going to be my marker for that. And then halfway between 1.5 and 4.5 would be 3. Would you agree?
Yes.
Okay. So what I'm going to do here is I'm just going to draw my cosine wave. Here my zeros are at the asymptotes of my cosine wave. So those are my zeros. And then this will be a maximum point. This will be a minimum point. So just a sketch of the cosine wave so that I can use its reciprocal to get one full cycle of my secant. So we're going to take and draw the reciprocal and approach your asymptotes. Same thing on the other side. And there you have one full cycle. Can't really get any more on there, but if I were to do anything, I might do this. I might do that just to indicate that it continues. Not important. I probably would if it was my homework. All right, so questions about that?
No.
Then you do D. Press pause, try it out, come back to the video, and see how you did. Okay, so there's a couple of cycles of the picture of this graph. Amplitude 3, period pi, phase shift 0, with asymptotes, because you have a horizontal compression here, you're cutting everything in half. Your asymptotes go from 0 to 2 pi, 0 to pi, with an asymptote right in the middle at pi over 2. And then one full sine wave between 0 and pi, and then I did another one between pi and 2 pi. Cut those in half, hit your peaks and your valleys, and draw your reciprocal function. So your assignment's on Canvas. It is called 9.2b, a further study. There are 8 problems.